Alright, it's that it cause, and in this video we'll be looking at hydrogen chloride gas. Hydrogen chloride gas was first prepared by John Priestley in 1772. Hydrogen chloride is a gas at STP and is highly soluble in water to form hydrochloric acid. So it is when hydrogen chloride gas dissolves in water that it forms hydrochloric acid. It can dissolve in non-polar compound like benzene, but it will not form an acid. It only forms acid inside water. It remains unionized inside non-polar solvent like benzene and the rest like that. How do we prepare hydrogen chloride in the laboratory? It is prepared by the action of conc H2SO4 on sodium chloride. When you react conc H2SO4 with sodium chloride, it gives you hydrochloric acid. As you can see the equation in this place, NaCl plus conc H2SO4. Now mind you, the NaCl must be in the solid form, and this reaction is possible because H2SO4 is a stronger acid than HCl. So I can use a sort of HCl, that is sodium chloride, to produce that HCl, because H2SO4 is a stronger acid and it's having higher boiling point than HCl. So you can use a stronger, less volatile acid to produce a weaker, more volatile acid, that is an acid with higher boiling point. It can be used to prepare another acid with lower boiling point. But if that other acid is stronger, and that is what we have in this case, H2SO4 is stronger than HCl, so I can use H2SO4 to prepare HCl by reacting the conc H2SO4 with a salt that contains chlorine, Cl, inside. So you can see here, the Na will react with the SO4, give us Na2SO4, and then the H will combine with the chlorine to give us HCl. So that is all about the reaction, and you are expecting, because it's a solid aqueous reactant, so you are expecting a round bottom flask with a tissue funnel inside it, as you can see in this place. As you can see here, you put your conc H2SO4 in this tissue funnel, and then your sodium chloride solid form inside here, and you heat it. If you heat it to high temperature, it gives you Na2SO4. But if you only use lower temperature, at lower temperature the product will be NaHSO4 plus what? Plus only one HCl. But if you heat it at high temperature, it gives you Na2SO4 and give you 2 of HCl. So it's always good to heat the mixture to get higher volume of HCl. So as you heat it with sodium chloride, HCl gas will be formed, and the HCl gas will be dried inside conc H2SO4, and then it will be collected by downward delivery, because it is because it is denser than air. So you collect it by downward delivery. How do you prepare hydrogen chloride industrially? You prepare hydrogen chloride industrially by direct combination of hydrogen and chlorine gas. As you can see in this place, hydrogen is burning inside a gas jar containing chlorine to give you HCl. If you bring ammonia gas near the product, it gives you white films of ammonium chloride. As you can see in the screen, you see that's ammonia. Now the vapor is giving you white films. That's test for hydrogen chloride gas, showing that hydrogen is burning inside chlorine gas to give us HCl gas. So that's how you prepare it industrially on a large scale actually. So if you need hydrochloric acid, you just dissolve the HCl inside water. So the reaction takes place in presence of sunlight using activated charcoal as a catalyst you activate a charcoal by heating the charcoal inside steam to a very high temperature, so it becomes activated. The surface area becomes increased. So that is how you produce HCl industrially in the presence of sunlight and activated charcoal. What are the physical properties of hydrogen chloride? Number one, hydrogen chloride is a colorless gas with a sharp irritating smell. It's an irritating smell. Then two, it is denser than air. That's why it can be collected by downward delivery. Denser than air. Number three, it turns moist blue litmus paper red, as you can see inside this video or this screen. When you put a moist blue litmus paper inside a gas jar containing HCl gas, it's going to turn red because the moisture will make the gas dissolve to form hydrochloric acid. So the acid will turn the litmus paper to red. Then it is highly soluble in water, and when it dissolves in water, it forms a strong solution of hydrochloric acid. Then HCl gas fumes strongly in moist air. When you have air that contains moisture, HCl gas fumes very strongly and forms droplets of hydrochloric acid. So when you open the gas jar of hydrogen chloride gas and the air around contains moisture, because HCl is highly soluble in water, the fumes of the HCl gas will dissolve inside the moisture of the atmosphere and drop back to the earth as hydrochloric acid. So that's why you are seeing those droplets there, those white fumes. Then it does not support combustion, and it neither burns. So it doesn't burn and does not support combustion. Dry hydrogen chloride can dissolve readily in both non-polar solvent and can also dissolve in polar solvent alike. But when it dissolves in non-polar solvent, it does not form ions. It does not form H plus and Cl minus. It just remains there as HCl. As you can see in this place, this is a non-polar solvent. So it dissolves in it but does not ionize. So if you put litmus paper inside a solution of hydrogen chloride gas in benzene, it will not change color because the hydrogen chloride gas does not ionize into H plus. It remains here as HCl, HCl, HCl. So there's no acid inside this solution of benzene now because benzene is non-polar. However, if you dissolve HCl gas inside water, it ionizes inside water to produce H plus and Cl minus. So in this case, if you put litmus paper inside this water now, it will change color and give us a red coloration because the HCl gas ionizes inside the water as H plus and Cl minus. So it's going to change color and it will conduct electricity also because there's iron inside the water. But the other one will not conduct electricity because it's a non-polar solvent. Benzene or toluene, they are non-polar solvent, or chloroform. So they cannot ionize hydrogen chloride gas. So it does not turn to ion there. Hence, it will not have any effect on litmus paper and it's not going to conduct electricity. However, the one inside the water will ionize, and because of that, it's going to change the color of litmus paper and it's going to conduct electricity. So this is how HCl gas behaves based on the solvent you are using, whether it is polar solvent like water or whether it is non-polar solvent like benzene. So this is the end of this video on the physical properties of HCl gas.